I'm John Burke, CEO and founder of UBIX. What you're looking at here is the UBIX platform. At a high level, UBIX is designed to do one thing: put AI directly in the hands of financial analysts and business users, without requiring them to write code. We've organized the platform into what we call spaces, each one representing a step in the end-to-end analytics and AI workflow. So instead of stitching together multiple tools, everything, from data access to modeling to deployment, happens in one environment. Let's start with data space, which is our analytic data layer. This is where data gets connected, organized, and prepared for analysis. We support 500 plus pre-built connectors to common enterprise systems, things like data warehouses, ERP systems, cloud storage. For example, here we can connect directly into BigQuery using secure credential-based access. Once connected, we can schedule data ingestion, automate refreshes, and even trigger actions back into source systems. And if a connector doesn't exist, we build it. That's part of the platform. We also support more flexible data inputs, flat files, URLs, cloud storage like S3. So analysts aren't blocked waiting on IT, they can bring in data as needed. Here's an example of structured data. Sales order headers coming from S4. We automatically profile the data, so it's immediately usable for downstream analysis and modeling. We also support unstructured data, things like documents, policies, compliance files. That becomes especially important in areas like risk and regulatory analysis. One important point here: all data is mirrored into data space. That means we're not putting load on source systems, and we're optimizing performance and cost in the cloud, so analysts can work freely without impacting production environments. Once the data is in place, analysts can interact with it using Chat UBIX. This is a conversational interface powered by LLMS, but designed for enterprise data. So instead of writing SQL, an analyst can just ask a question. Behind the scenes, UBIX generates SQL dynamically and runs it against the data in DataSpace. And importantly, your data never leaves your environment. We use a RAG framework to ground responses in your data, reduce hallucinations, and ensure the outputs are reliable. Now, where analysts spend most of their time is model space. This is where solutions are actually built. Everything is organized into workspaces so teams can collaborate while maintaining control over access. An analyst can build models, run experiments, and operationalize workflows, all visually. This is the environment where the FP&A use case you're about to see was created. And throughout all of this, governance is built in. Access is controlled through role-based permissions, so users only see what they're supposed to see. All data is encrypted, activity is logged, and the platform meets enterprise standards like SOC 2 and HIPAA. Now let's take a look at a day in the life of a banking FP&A analyst, starting with a simple question. We missed revenue. What happened? Will it happen again? And what does it mean for the bank? We're currently in Q4 2026. Q3 2026 is the last completed quarter, and any Q4 data you see is quarter to date, still in progress. Let's begin with the bank's vital signs. At a high level, this is a large institution, about $46 billion in loans and $35 billion in deposits. That gap, roughly $12 billion, is funded through wholesale markets. That's important because that funding cost is going to show up later in the story. Now look at profitability. NIM is 2.95%, within normal range for a commercial bank, but showing a compression of 35 basis points from its prior level. ROE is 10.8%, just under the 12% cost of equity. So we're right on the edge of destroying shareholder value. Operational efficiency at 61%, that is healthy. Operations are not the problem here, and credit quality looks completely fine. NPL below 1%, 90-day delinquency at 0.43%. Borrowers are not defaulting. Just hold that thought, because that becomes the key insight later. Now let's move to the CFO dashboard. Top left, NII variance by business unit. Corp banking is down $22 million in Q3. The other divisions are basically flat. So this isn't a macro problem hitting the whole bank, it's fully concentrated in one division. Bottom left, CET1 ratio, flat at about 9.2% for 20 quarters. From a regulatory perspective, the bank looks completely safe. That's going to matter later, because it creates a tension between safety and performance. So the next question is, was this building over time, or did it just happen? Looking at the heat map, you can trace corp banking across 20 quarters. From 2022 through mid-2026, you see small misses, maybe $500,000 to $2 million per quarter. That's normal. Background noise. Then suddenly in Q3 2026, it drops to negative $21.7 million. That's not a trend, that's a structural break. And in Q4, quarter to date, it's already negative again. So the issue is continuing right now. Now let's go one level deeper. Which products caused it? 3 products explain almost the entire miss. Variable term loans, about minus $11.3 million. Equipment and operating leases, about minus $5.2 million. Fixed term loans, about minus $4.8 million. All 3 share the same characteristic. They are multi-year contracts with pricing fixed at origination. So when funding costs move, the bank cannot reprice the asset. Now let's quantify exactly what happened using the waterfall bridge. We start with $78.5 million of expected NII. Then, asset yields drop to minus $8.1 million. Funding costs, FTP, increased to minus $13.8 million, the largest impact. Volume had a small effect. Hedging and FTP offsets recovered about $13.3 million. We land at roughly $56.5 million actual NII. And importantly, this fully reconciles. Every dollar of the miss is accounted for. But here's the key limitation. The waterfall tells us what happened mechanically. It does not tell us why corp banking couldn't absorb it while the other divisions could. That's where we shift to AI. Now we move into the machine learning model. This model is trained on about 42,000 transactions over 5 years. It explains about 71% of the variance, which is strong for financial data and better than typical arithmetic approaches. Now look at what it finds important. The top signal is change in asset yield, yield compression. The lowest signal is probability of default, essentially 0. So the model is picking up a very specific pattern, compressed yields plus near zero defaults. That's the fingerprint of a prime institutional borrower portfolio. Let me briefly show you how this is built. Everything you're seeing in this FP&A demo is created here in model space. It's organized as a simple tree on the left, data access, what you're permissioned to use. Solutions, where workflows are built. And apps, where those workflows are turned into analytic views and dashboards. At the center is the visual workflow. Each step you see here is what we call an action. An action takes data in, transforms it, and passes it to the next step. So over time, you're building a full data pipeline. Under the hood, these are things like SQL and Python. But for the analyst, it's all point and click, no code. For example, here we're selecting and shaping the raw transaction data. You can see profiles, adjust data types, and immediately preview the output. Next, we join in additional data, in this case, macroeconomic inputs. Then we create new variables. This should feel familiar. It's a worksheet-style interface, very similar to Excel. But unlike Excel, it scales to millions of rows without breaking. And here is the machine learning model we use to derive the variance driver attribution model. It's just another step in the workflow, fully integrated into the pipeline. Once the workflow is ready, we can productionize it with one click. From there, we can monitor execution, manage runs, and even trace column-level lineage all the way back to the source data. Turning back to our analysis. Now let's compare 2 views of the same problem. First, the rule-based view. It shows Q3 driven by rate and hedging effects. That's correct. Those are the mechanical drivers. Now switch to the machine learning view. Completely different story. Rate impact is still large, negative $12.9 million. But now credit quality shows up as a major driver at negative $8.7 million. And hedging disappears entirely. Why? Because the model is asking a different question. Not what moved, but what made the bank vulnerable to those movements. And in Q4 quarter to date, already negative $5.9 million with the quarter still open. Same pattern, accelerating. Here's the insight. Corp banking focused on AAA, AA clients. Those clients are extremely safe, but they negotiate very thin spreads. So instead of earning 300 basis points over funding, the bank is earning something like 40 basis points. Now combine that with a rate shock. If funding costs rise by 50 basis points, a 300 basis point portfolio survives. A 40 basis point portfolio goes negative. That's exactly what happened. So this is not just a market event. It's the result of a strategic choice. The bank optimized for credit safety, but in doing so, it eliminated its margin buffer. The traditional analysis found the symptoms. The ML model found the cause. So now the question becomes, does this continue into 2027? We use a time series model to forecast forward. This model projects NII forward and continuously retrains as new data comes in, including the current quarter. Now let's look at credit assumptions. In the base case, default rates are about 1%, very low. In mild stress, defaults increase, but still within a manageable range. And here's the paradox. Low default risk protects capital, but thin spreads destroy profitability. You can't optimize for both. Now look at the NII forecast itself. All scenarios remain positive. The bank survives. But the spread between scenarios is wide. That spread reflects macro sensitivity caused by thin margins. Now we bring it all together with the CET1 forecast. Across all scenarios, the bank stays above regulatory minimums. No breaches, no alarms. From a regulator's perspective, everything looks fine. But here's the twist. The base case is actually the weakest outcome, because in normal conditions, the loan book grows. Risk-weighted assets increase. Earnings don't keep up, so capital slowly erodes. Under stress, the opposite happens. Borrowers pull back. The balance sheet shrinks. CET1 improves mechanically. So the bank actually looks stronger under stress than under growth. Now compare that to the returns dashboard. ROE in corp banking approximately 10%, below cost of equity. RAROC is the lowest of all divisions. EVA has turned negative, including Q4 quarter to date. So while capital looks safe, the bank is actively undermining shareholder value. So we have two truths. The regulator sees a safe bank. The board should see a value problem. And they come from the same decision. There are three levers. Reprice the portfolio. Introduce minimum spreads. Rebalance product mix toward higher yield assets. Resize hedging to match the actual exposure. UBIX didn't just identify the variance. It traced a $22.1 million miss all the way back to a strategic decision. The traditional analysis showed the symptoms. The AI/ML model revealed the cause, and the forward view showed the consequence. The bank is overcapitalized and under-earning, and the time to act is now. With that, I'll hand it over to the question and answer.